Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve this related rates word problem. As per the word problem, a boat which is 3 meters below the dock is being pulled in by a cable. When the boat is 4 meters away horizontally from the dock, it is approaching the dock horizontally at a rate of 5 meters per second. How fast is the cable being pulled in? The first step is to draw a diagram for this problem. Let's assume the dock is at point D. The water level is 3 meters below the dock because the boat is 3 meters below the dock and is being pulled in by a cable. Let's assume this is the water level and the boat is at point B. The chain is represented by the line segment DB. And the dock is 3 meters above the boat. Let's assume at any point in time the boat is at a distance x horizontally from the dock, and as per the problem the boat is approaching the dock horizontally at a rate of 5 meters per second when the boat is 4 meters away from the dock. Therefore dx over dt is equal to -5 meters per second at x equals 4 meters. The value of dx over dt is negative because the boat is approaching the dock, and as a result the value of x is decreasing over time. This is a very important concept we need to understand to solve this type of problem. We can draw a right angle triangle in this diagram by drawing a line straight down from point D. When the boat is x meters away horizontally from the dock, let's assume the length of the chain is L. We have to find how fast the cable is being pulled in. So we have to calculate dl over dt. To find the value of dl over dt, we need to write an equation with variables L and x. We can use Pythagorean theorem equation to write that equation because we have a right angle triangle in the diagram. As per the Pythagorean theorem equation, in this equation c represents the length of the hypotenuse and a and b are the lengths of the other two sides of the triangle. Next we can apply square root to both sides. We have to find the derivative of this equation with respect to t. Before we find the derivative, we should change the square root to rational exponent 1 over 2. Now we can find the derivative. On the left side, the derivative of L with respect to t is dl over dt. On the right side, we have to use chain rule to find the derivative with respect to t. The inner function is 9 plus x squared. The outer function is the exponent half. As per chain rule, we start with the derivative of the outer function. We have to use power rule. We move the exponent half to the front of the term and subtract 1 from half times the derivative of the inner function 9 plus x squared. 9 is a constant, so its derivative is equal to 0. We have to use chain rule to find the derivative of x squared with respect to t. The inner function is x, the outer function is the exponent 2. As per chain rule, we start with the derivative of the outer function. So using power rule, we move the exponent 2 to the front of the term and subtract 1 from 2 in the exponent times the derivative of the inner function x. The derivative of x with respect to t is dx over dt. Now we can simplify this equation. In the exponent, half minus 1 is negative half. The exponent of x is 1. X to the power 1 is just x. Next, we can move the term 9 plus x squared to the denominator to make its exponent positive. We have to find dl over dt when the boat is 4 meters away horizontally from the dock and it is approaching the dock horizontally at a rate of 5 meters per second. So we should sub in x as 4 and dx over dt as negative 5. Four squared is 16. 2 times 4 times negative 5 is negative 40. 9 plus 16 is 25. 25 to the power half is equivalent to square root of 25, which is equal to 5. Negative 40 over 10 can be reduced to negative 4. And the unit is meters per second because that's the given unit for rate of change in the problem. We get a negative answer for dl over dt because as the boat approaches the dock, the length of the chain decreases. That's why dl over dt is a negative value. This should be the final answer for this problem. So these are the steps you have to keep in mind to solve a problem like this one. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.